Hi, Assalamualaikum. My name is Fatimah Az-zahra. So in this video, I would be sharing the details of the DC power supply system that me and my groupmate designed, providing stable 12 and 5 voltage outputs for this circuit. So the foundation begins with a 240 VAC input, ensuring reliability with a tolerance of ±5%. Our 2B to a step-down transformer, which changes the incoming voltage and keeps the input and output circuit separate, boasting a 50 to 1 turns ratio and an ideal coupling factor of 1, which allegedly steps down the voltage to 4.8 V for optimal performance. This transformed AC voltage then encounters a generic bridge rectifier, efficiently converting it into pulsating DC. To ensure a clean output, a filtering stage follows, featuring 3 capacitors, 0.1 microfarad, 100 microfarad, and 47 microfarad, collectively reducing ripple and providing smoothing effects. As a protective measure, a 10 ohm resistor is strategically placed in series with the output for current limiting. Finally, the circuit is regulated by the IC regulators, which is IC7812 and IC7805 for the 12 and 5 voltage outputs respectively. So these regulators maintain a steady output voltage even under varying loads and input conditions, ensuring a reliable power supply for diverse electronic applications. So the next slide shown is our schematic design circuit, enhances the overall communication of the circuit's design and functionality. It serves as a critical visual aid and reference for understanding, implementing and evaluating the electronic circuit that will be described in the next part of this video by my fellow groupmate, SYUKRI. That's all from me, thank you.
Now I will explain on the results. So this is the circuit diagram that we have made. So as you can see, this is the alternator that is supplying the 240 AC voltage with a 50 Hz, and it is a 50 to 1 ratio with a 1 coupling factor. So the AC output of the transformer is a sinusoidal waveform that cycles between the positive and negative values. So to convert the AC to DC waveform, we have to use a bridge rectifier, and in this bridge rectifier we can see that this is the input waveform that it has made. The yellow colored one is the input for the AC signal. So basically the bridge rectifier corrects the AC waveform by allowing current to flow in a single direction alone during the positive and negative cycle. So the output bridge is not a pure DC wave, but it is called the pulsating DC wave. Basically it is a mixture between the AC and DC waveforms. Then after that we use a capacitor to filter out this waveform. So basically it smooths out the output waveform, and then after that we use a capacitor to filter out this output that was made by the rectifier, so that the output that will be produced will be smoothened out for it to be a better DC waveform. The values that we have used is 0.1 microfarad, 100 microfarad, and 47 microfarad. So basically the capacitor stores charge during the peaks of the pulsating waveform and release it when the voltage decreases, effectively reducing the ripples. So eventually it will smooth out the variations in the rectified waveform, resulting in a more stable DC output. Here we can see that the result that we have gotten from this oscilloscope, we didn't obtain the actual of how you would supposed to get the ripple output voltage. As you can see, this is the blue colored one is the input for the before it enters the rectifier, the input for the rectifier, and this is how it was supposed to look like for the red one. And for the ripple voltage, like I've said before, we didn't get the actual result due to some unknown reasons, or also because of the lack of knowledge that we possess. So it was supposed the output waveform was supposed to be like an ocean waves, where it will to be like a ripple like waveform, basically like this. So after it passes through the filter section, where after it passes through the capacitor, it will enter the IC regulator. So basically we have used two IC regulators, which is IC7812 and IC7805. So basically 7812, it produces an fixed output voltage of positive 12 DC voltage, and for the 7805 it will produce a fixed output voltage of positive 5 voltage DC. And then after that, the IC regulator is able to supply a constant and regulated DC voltage to the load. So the load that we have used is only 10 ohms, and as you can see, we have obtained 0.50 ampere. So it has met the requirements for this assignment. And in our oscilloscope, the green signal here is for the constant and regulated DC voltage to the load. So in conclusion, the simulation is achieved successfully with the alternator was supplying 240 AC voltage at 50 Hz and the output voltage of positive 12 and positive 5 DC voltage by using the IC regulator of 7812 and 7805. And finally, an output current of 0.5 ampere. So the alternator generates an AC waveform that is converted, rectified, filtered, and regulated before being given to the load as a constant and regulated DC voltage. So every stage of this procedure is critical to turning the generator's electrical power into our functional and dependable daily form of electronic devices. And finally, here are the references that was used in the help of making this report. So once again, thank you for watching.